For this video, we're going to review solving inequalities and then solve absolute value equations. And we'll save the absolute value inequalities for in class tomorrow. So to start with, solving inequalities is just like solving equations except for one important step. You've got to remember whenever you multiply or divide by negative, you have to switch that sign. So switch your inequality sign anytime you multiply or divide by that negative. So for example 1 here, we've got negative 3x plus 7 is greater than 19. So I want to get x by itself. So I'm going to start by subtracting 7. So we get negative 3x is greater than 12. And then I'm going to divide by that negative. Too far. I'm going to divide by that negative 3. And because I'm dividing by a negative, it is going to get on my last nerves. We're going to have x is... I don't understand this. Maybe. There we go. X is less than negative 4. Drive me insane. Alright, so we switch from greater than to less than. Over here, for example, 2, we've got like a multi-step equation. So I'm going to start by distributing that 3 to that parentheses. So we've got 3p minus 6 is greater than or equal to 2p plus 7. And now I need to get my p's on the same side. So since the 3p is bigger, I'm going to leave it there and move the 2p. I'm going to subtract 2p. So we get p minus 6 is greater than or equal to 7. Now I need to move my 6 over. So then we get p is greater than or equal to 13. And we didn't have to switch anything there because we didn't multiply or divide by a negative. Alright, compound inequalities is when you have two or more inequalities joined by that and or. So and is an intersection, so it's picky, right? Remember, probability has got to be all of those situations. And or is either or. It's a union, so it's not as picky. So if we start by just kind of graphing these on a number line. So for example, 3, x is less than 4 and x is greater than negative 3. Alright, so I'm going to put negative 3 and 4 on the same number line. So we got negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Alright, and I want all the x's that are less than 4. So that's an open circle, and I'm going to shade to the left. Then I want all of the x's that are greater than negative 3. So I'm going to put an open circle and shade to the right. So my solution area is in between negative 3 and 4. That's where they both are, not including negative 3 and 4. For example, 4, we have x is greater than 4 or x is less than negative 3. So if I have x is greater than 4, go down over here to the 4, maybe. There it is. And we'll come over here to negative 3. So x is greater than 4 means I have my circle, I shade to the right. And then have my circle shade to the left for negative 3. So all of this is my solution area. So it's everything except in between negative 3 and 4. So solving these compound inequalities, here we have the and. So my first one is 1 minus 4x is less than or equal to 21. We're going to start just by solving like normal. So I'm going to subtract the 1 from both sides. So we got negative 4x is less than or equal to 20. And then divide by negative 4. I'm dividing by negative, so I've got to switch my sign. So I have greater than or equal to negative 5. And then over here, we've got minus 2. So 5x is greater than or equal to 20. Divide by 5. X is greater than or equal to 4. So if I go to my number line, just to get an idea of what this looks like, I got a 4 and a 5 on there. So I want all of the x's greater than or equal to, negative 5, sorry. Negative 5's down here. Alright, so I got a closed circle because it's or equal to, and I'm shading to the right. Then over here, x is greater than or equal to 4, so I'm going to come to 4, put my closed circle, shade to the right. So it's got to be where both of these are. So that's everything that's to the right of that 4. Because of that, this greater than negative 5 is kind of overpowered, so my answer is just greater than or equal to 4, because that includes where the and is. And then at number 6, it's the same kind of setup, except we've got two different sides here. So I'm going to do the same thing to all my sides. So if I start by subtracting 5, I'm going to subtract 5 from all of my sides. Negative 3 minus 5 is negative 8. And 17 minus 5 is 12. And then I'm going to divide by 3. I'm going to divide everything by 3. So then I get negative 8/3 is less than or equal to x is less than 4. And I can leave it like that because this is saying everything that's between negative 8/3 and 4. Alright, here's an OR example. So I've got 1 minus 2x is greater than 3, so I'm going to subtract my 1. So negative 2x is greater than 2. Divide by negative 2, dividing by negative, got to switch my sign, so x is less than negative 1. If I come over here, add my 4, 2x is greater than or equal to 8, divide by 2, so x is greater than or equal to 4. Alright, so these are my ORs. I'm going to graph them just to see if there's a way of simplifying. So I've got negative 1 and 4. I've got an open circle and negative 1. I want all the x's less. And then over here, I've got a closed circle because it's or equal to, and I want all the numbers to the right. So there's no way of simplifying it, so we're just going to leave it as x is less than negative 1 or x is greater than or equal to 4. Alright, here we go again. We've got an OR on this side, so I'm going to add 2. So x is less than 5. And over here, subtract 1. So 2x is greater than 4. Divide by 2. X is greater than 2. So if I sketch those, we got 2 and 5. So I've got an open circle on the 2. I want everything to the right. Open circle on the 5, everything to the left. Now this is one of those cases where because it doesn't have to be the both, it's just anywhere that either one of them are, this covers the entire number line. They overlap each other. So my answer to this one is actually all real numbers because they overlap and they end up covering everything. And then for example 9, this one's an and because it's one big inequality. Just remember whatever you do to the middle, you do to both of the outsides. So I'm going to start by subtracting that 4. So we get negative 10 is less than or equal to 2x. It's less than or equal to 4. Divided by 2. So we get negative 5 is less than or equal to x is less than or equal to 2. So x is between negative 5 and 2. And we'll try to put a circle around that. Alright, so we're going to keep moving and get into absolute value. So remember, absolute value is always a distance from 0, so it's always positive because we can't have a negative length. Our steps for solving absolute value equations is first to isolate the absolute value bars, split it into 2 equations, and then solve for 2 answers. Alright, and we'll talk about that more here. Let me get my pen back. Alright, so for this first example, we've got the absolute value of just a general example with A, B, and C. And so we're saying the absolute value of this equals C. Well, because we know that whatever's in here is going to always be positive, we could have it positive or negative. But no matter what, it's going to be a positive C. So we break it up into 2 equations, and this is actually supposed to be a negative C. Right? So for example, if I said that the absolute value of x equals 5. Well, I have 2 possibilities. The absolute value of 5 equals 5, so we'll have one equation that's 5. But the absolute value of negative 5 also equals 5, so x could be negative 5. Right? So that's all we're doing. We take whatever our absolute value is, and we have a positive and a negative. Well, if it's 0, the absolute value of x is 0. That means it's 0 units from 0, so I only have one answer, or I only have one option, and that's to set it equal to 0. So we don't have 2 equations, you only have one equation whenever you're working with 0. And then if we have a negative, so for example, the absolute value of x equals negative 2, well that's impossible, so it's no solution. Alright, the absolute value always has to equal something positive in your initial equation. So for example, we have the absolute value of negative 3x plus 4 equals 5. So my absolute value bars are separated. They're already by themselves, isolated. So I'm just going to break it into 2 equations. So we have negative 3x plus 4, maybe, equals a positive 5. Nope. There we go. Equals a positive 5, and then negative 3x plus 4 equals a negative 5. So those are my 2 equations, so I'm going to solve. So I'm going to start by subtracting 4. So negative 3x equals 1 divided by negative 3. X equals negative 1/3. Over here, same thing, subtract 4, but now negative 5 minus 4 gives us negative 9. Divide by negative 3, so x equals positive 3. So I have two answers, x equals negative 1/3 and x equals 3. All right, example 11. Same idea, but I've got this 3 on the outside that I've got to get rid of first. So this is 3 times the absolute value of 2x plus 1. So I'm going to start by dividing by 3. So I've got the absolute value of 2x plus 1 equals 9. Now I've isolated the absolute value, so I'm going to break it apart. 2x plus 1 equals 9. 2x plus 1 equals negative 9. And then solve. Subtract 1. 2x equals 8. Divide by 2. X equals 4. Same thing, subtract 1. 2x equals negative 10. Divide by 2. X equals negative 5. So my two options are negative 5 and 4. In our last example, we have the absolute value 2 minus x plus 5 equals 13. So right now I've got to get that absolute value isolated. So we've got the absolute value of 2 minus x equals 8. And now I can split it up. So 2 minus x equals 8. 2 minus x equals negative 8. All right, I want to solve, so I'm going to start by getting rid of the 2. Try to get rid of the 2. And I don't know what's going on with my pen. Minus 2. So then we get negative x equals 6. 6, maybe. Goodness gracious. All right, and then I want to get rid of that negative. Oh, goodness. So I'm going to divide by negative 1, divide by negative 1, so we get x equals negative 6 over here. Same thing on this side. I'm going to subtract the 2 first. So we get negative x equals negative 10. Apologize for how sloppy this is getting. Divide by negative 1, x equals positive 10. So my two options are negative 6 and positive 10. All right, so absolute value, isolate, split, and you solve.